Hello, guys. This is Kelly from Group 6, and we'll be doing a presentation on the iGraph tool or the package, which is a tool used for creating and manipulating network graphs and analyzing networks. Okay, so as we've already done in the presentation, we've actually given a brief intro to what the tool is and what it does and what it can do and what it cannot do, right? So, as stated in the presentation, it is a package indeed, right? So ideally, the iGraph tool can be run on its own. So it was written in C and it also exists in R packages. So talking about the R packages, this when I'll have to maybe go into detail with what the R is. Okay. So the R is a programming language which means research, which was created by researchers and all. Okay. So and the R Studio is the IDE for the R programming language, right? So the R Studio has a host-based application, also a cloud-based application. So what we have right here on our screens, on my screen, sorry, is the studio, the R Studio for the cloud. Okay, so what this one does is that it just gives you some sort of software as a service where you don't have to worry about computer resources with regards to memory, RAM, hard disk space, and all that. So everything is being set up in the cloud, and all you have to do is just use your web browser to access it. Okay. So to start off, I'm going to go over the interface here, right? Okay. So there are actually four areas. So we have the console, right, which is what you tell the R Studio, as in with command execution and stuff. And we also have the environment history connection section, which actually gives you the variable, the history of commands run, the connections, and it also has a self tutorial where you need to install a particular package. Okay. Then we also have the file plots packages where it actually gives you some sort of a file folder space where you can actually upload documents, which we will be doing later on in this presentation. And also it has a plot section where in case you want to plot a particular data set that you're actually going to input in the R Studio. And it also has packages, which gives you a list of packages available where you can install and all that. So basically in the help in the viewer speaks for itself. Okay. So as we said, so yes, the iGraph is actually used to creating graphs and analyzing network data, right? Okay, so to start off with this project, we want to create our own kind of network data, something that could be easily built rather than going in for an already existing social network media data, which is maybe has vast data, which will be a bit hard for us to demonstrate. So we'll just go with something simple for now. Then we'll see how we can apply that in future data sets. Okay, so first and foremost, yes, so as I said, this is the R Studio Cloud interface. And to start off by using iGraph is not installed by default in R Studio, so it's something we have to install. Okay, so to install the our iGraph package, you need to go to packages. Okay, then you scroll down to, okay, so you go to packages and you click on the install, right? And the install gives you an interface where it asks you for the package you want to install. But actually, there are options with the install from, where it goes like you want to install from a repo, which is actually the CRAN. Those are the people in charge of the iGraph package or any package regarding the R Studio. Okay, so we just keep it at default and we just search for iGraph. Okay, so there it is. Then it installs to the default library for the R Studio on the cloud, and we need to check the dependencies. This dependency needs to be checked in the sense that there might be some other tools that will be needed by the R Graph to run in this R Studio cloud. So we just need to keep that checked and all that. So we install. Okay. So as you can see, it's running the install packages. So ideally, we could have just run that command too, but so that's another way of installing the iGraph package on the R Studio Cloud. So it's going to take a couple of minutes, maybe a minute or two to get that done. Let's see. Okay. Okay. So iGraph is done. It's installed. Okay. So let's go back to the packages and see if we do have the iGraph. Yes, so iGraph is indeed installed in the user library and it's version 1.26, as you can see, 1.2.6. Okay, so now let's go on and so Control L will just clear everything on the screen. So now let's go back to default. Okay, so now we want to use the iGraph to maybe create some data and see how iGraph can be of help here. Okay, so we need to create a new R script. Okay. Okay, so there's a script that we created. And so first and foremost, with this, we need to call out the package that we just installed. Okay, and you could see that by default it has given me an idea of all the packages that are currently in the R Studio. Okay, and we have the iGraph in here. So we're just going to either you can type it or just select it, right? So this command actually calls out the iGraph package. Okay, so the next step we will need to create some sort of data. Okay, so I'm going to call it group 6. I'm going to call it group 6 network 1. Okay, and it's also advisable that yes, we do create their names so that they are with no spaces in between them. And the best way to go about this is putting maybe underscores or hyphens in between them. Okay, so the name of okay, there are so many underscores. Let me just make it 2. Okay, so group 6, network 1. Okay, so that's the name of the first data set I'm going to create, and we need to create an arrow linking it to a particular function or data. Yeah. So group 6, network 1. Then we use the graph command. Okay, and what does the graph command do? Okay, so with the graph command, that's what enables us to actually create the nodes or the members of the data set. Okay, so command its edges. So C, okay, so this C actually is a formula that needs and that's needed in the iGraph package when you're actually creating your data set. So I'm just going to go over, like I'm just going to go ahead and just create the data set. Okay, so the edges. So with this, I'm going to create the data sets as I already stated. So we put them in double quotes. So for instance, so I'm creating a sample data Solomon and Habitat. Okay. So what this means is that I'm actually saying that with my data set, Solomon is linked to Capitata. Okay. So yes, so we have Solomon and Capitata. Yeah, so as I stated earlier, so with this group 6 network 1 that I'm creating, right? I'm creating a graph which has edges, Solomon and Capitata, which are linked together. Okay, so I'll just have to create. So yes, so let me just add a few more edges. Okay, so Solomon and Capitata, and who else? Let's say Brew. Okay, then I'll link um, Brew to Doggy, right? Okay, then I'll link Doggy to Capitata, right? Okay, then let me just add a few more. So let me make Doggy um, to Vinny. Okay, okay, then brew to some. That'll be the final one. Okay, so brew sample. Okay, so cool. Okay, so we created a data set. Okay, so let's call out the group six, right? Okay, then the next one, okay, so let's call out the group six and see something. Okay, so with this already created, with this data set I've created, group six network one, I've called out the same group six network one. So let's run the code and see what happens. So you go to code, run region, and you run all. Okay, and let's see what happens. Okay. Okay, so from here we'll see that yes. So the group six network one that we've called, it actually says, okay, so Solomon is linked to Capitata, Capitata is linked to Brew, Brew linked to Doggy, Doggy Capitata, Doggy Vinny, Brew someone. Okay, but from here we can see that it has this arrow looking alike link, right? Okay, which goes on to state that this is more of a directed data set. And when I say directed data set, I mean a data set in which, yes, from what this one is saying, it's saying that indeed Solo is linked to Capitata, but Capitata not linked to Solo in that sense. But that's not what we want to achieve here. So we need to add another clause or conditional statement or something like that, which goes like directed should be equal to false. Okay, yeah, so that should be it. So now let's clear this. Control L will clear it, and now let's run the code again. Okay, so now you could see that Solomon, Capitata, and all that is not really a directed data set. So um, for example, as we're doing our research, a typical example was that yes. So if it was a directed, you were saying that yes, Solomon could actually play maybe tennis with Capitata, but Capitata is not playing tennis with Solo. So that really wouldn't make sense with this data set. So to actually make sense, we actually have to make it undirected. That means the directed clause will be false. Okay. Okay, so that's done. So let me clear this one. Okay, so with iGraph, what else can we do? We can actually plot this to actually have a graphical presentation. Okay, so we are using the plot command and we go with the group name. Okay, so group network one. So the same thing, we go through code, run region, and run all. Okay, so as you could see, it gives you the details of the edges of your data set and also it plots uh, the group six network one. So as you could see, pair the links that we created in the data set. So someone linked to Brew, Brew linked to Capitata, Capitata linked to Doggy, Brew linked to Doggy 2, Vinny and all that. So all the members in our data set, all the edges, all the nodes are represented in this graph. Okay. Okay, so this is actually pretty simple, right? We've actually manually created our own data set. Okay. So what if we don't want to do it this way? Let's say we have a larger data set, which will make manually typing the nodes in our studio a bit cumbersome and full of errors, if I should say. So there's also another way where we could actually call out the upload of a file, preferably a CSV file, right? So let's go with that one too. So let me just clear everything, okay? And with the plots, you could just brush here. We could just clear all plots. Okay, so yes, let's do that. Okay, so now let's create a new network, okay? So the new network we're going to create is group six network two. Okay. Okay. But before we actually create a group, we need to create the data that we want to import. So we're saying we're looking at importing a file, preferably a CSV file, right? So we actually need to create a group six data set, okay, a data which will actually read .csv, okay? So it reads a .csv, and the options available are the file .choose, which gives you the opportunity to choose a file, okay? Okay, yeah. So the file that we have, I actually have a file opened here called network user list, okay? So with network user list, as you can see, I have edges connected to each other. So I have Chisom Vini, I have Vini Kelly, Kelly Solomon, Solomon Doggy, Solomon Viola, Viola, Jore, Asil, Aquaba, same to you, Chisom. Okay, so this is the sample data list that we're going to. So assuming this was a bigger set, right? So it will actually good to actually upload a CSV file instead rather than typing them manually. Okay. And also something that yes, so there's also something that you should take notice regarding the CSV upload. Okay, so you can see that this one has no headers. Okay, so straight from A1, we are talking about the edges, the nodes that we actually need in our data sets. Okay, so there's also an option that we have to include in our command here, which is header. Okay, and the options are true or false. But in this case, false because there's no header in our CSV file. Okay, okay. So now we'll go to our actual group six underscore network underscore two. So the command will be graph data data dot frame. Okay, and we have to actually call up the group six data. Yep. Okay, and also, so let's say in this case, let's say the directed. Yes, so we need to also check the directed. As I explained earlier, the data could be directed or could be not be directed. But in this case, in the first example, we did directed to be false. So this one, let's do it true. Okay, and see what happens. Okay. Then in our first example, after stating all that, we had to call out the group, set network two, then also plot it, right? Okay. So since we already have a feel of the first network, so let me just comment that one out. Okay, so now let's run it and see what happens. Hopefully everything goes according to plan. Okay, so funny thing, so it's actually asking us to choose a file, and that's something I forgot to do. So we need to, since it's not running on our local machine, there's no way we could call out that CSV file I showed you. So we need to upload it to our Studio Cloud for it to run. Okay, so you could see that error file choose, file choice cancelled. So we need to go to the file section here and upload the file. Okay, so we browse for the downloads network user list. Then we okay, so as you can see, the file has been uploaded. Okay, so now let's Control L and run the code again. Okay. So it's asking us to choose a CSV file, right? So the one that we uploaded, network user list.csv. So we open it. Good. Okay. So you could see it has actually, with the group six network two that we called, that actually gives us details of all the edges. And since it's directed, yes, we have the arrows linking to the other nodes. So as I said, Chisom Vini, Vini Kelly, Kelly Solomon, Solomon Doggy, Solomon Viola, Viola Jore, and all that. So yes, and also the plot section also gave us a beautiful circular with a pointed arrow kind of look. So yeah, so there's also another way of getting the data imported by using the read.csv function, and also plotting that as well. Okay. So that's it for the data input. So now let's try and see if we can do some analysis with what we have. Okay. Okay. So we want to run analysis on the first network that we set. Okay. The group data that we set. So let me comment these one out and let me open these ones. Okay. Let me clear these guys. Clear you too. Okay. So iGraph has a couple of features that could be used to calculate certain elements in our data set. Okay, so let me just run. Let me just run what we have so far. Those commented out. And won't appear anymore. Okay, so back to our old um, data set. Okay. Okay, so with this data set, we could run a couple of calculations, which iGraph has the ability to, so that we could actually make sense of the data. Okay, ideally, this is something very simple. So from the top of our heads, we could actually calculate any things. But let's assume it was a larger set. Okay, iGraph is particularly helpful with this. So if it was a larger set, it will be able to actually give us an idea, make some certain analysis of our data set that will make sense to us or the suggested audience. Okay, so with the things that we could run. The calculations that we can run to make the analysis. For one, there's one called betweeners. Okay, so what betweeners does is actually calculates the shortest path between pair of nodes in a network. Okay, or measures the nodes that are congruent. Okay, more like the nodes that are in the middle, more or less. Okay, so the command is betweeners, and we have to call in the data that we want. So that's the group six network one. That's the first one. Okay. Yes, and also with this one, we need to specify the directed. Remember, in the first data, the directed was false, so we need to also keep it here. Okay. Then also, there's also closeness. Okay, so what closeness does is it calculates the distance between the nodes, between one node and all other nodes. Okay, and I'll explain into details after we run so that I could explain the calculations used here. Okay, so with the closeness, you have to call out the network one as well. Okay, then there's also something called degree. Okay, so the degree also calling the group six network one. But it also has a function called mode. Okay, so mode it has functions mode all out in total and all. So we'll go with the all, which is preferable for undirected data sets. The in and out could be used for the directed data sets. Okay. Then we also have the edge density. Edge density. Okay. So the edge density for network one. And we also have the diameter, which is the longest distance of our data set, more or less. Yeah. So group network one. I could actually have typed this, but our studio makes it helpful by providing the options, making it easier for you to just go ahead. Yeah. And we also have distances of our group data one, and also has a mode of all. Okay, has a mode of all. Yeah, so I need to put that all in. Sorry about that. Okay. Then after distances, there's clicks. Okay. So clicks actually so let's say if I wanted to find out of this data set that we have down here, if I wanted to find let's say nodes that are connected together. Okay, so for instance, so clicks of the group network one data with a minimum of let's say two. So with this option, what's going to tell me? It's going to give me data as to which two nodes are connected together, right? But from here, I'm sure we'll get a lot. So let's increase it to three. So that will actually tell us three nodes or three edges that are connected together. So we have articulation point. So this one, what it actually does is that, yes, you could see that all these nodes are connected some way to make one beautiful network. So what this articulation point does is that it actually tells you which nodes or edges are the most important in the setup in the case that when they are actually taken out from this data set, there's going to be a breakdown of the group into smaller groups, right? So these are more like the holding points of the network, okay? So it's actually going to tell us which edges or which nodes are actually the holding blocks of this whole network setup, okay? So the group network data one, and also there's also a component option. So there's also a component, oh my bad. So there's also a component, okay, a component for the group six network one. So we've had a couple of tools that we could, or maybe let's say ways we could calculate certain things. So we have the betweeners, the closeness, the degree, the edge density, the diameter, the distances, the clicks, articulation, and the components. Okay, so I'm going to run this data and fingers crossed this thing works out. Okay, so let's run everything and see what it tells us. Okay, so I think it's been able to run certain things. Okay, so you can actually click this part here to make it larger. We don't need to go through the code again, so we just want to make sense of the data that's been given to us. Okay, so from the command run, yes, so we called out the package iGraph, and we created a group 6 network one as we did earlier in this presentation. It's a bit truncated because the data seems a lot. Okay, and the edges, so we called that the group 6 network one, which actually gave us um, the connection, so the nodes connecting to each other and all that. Then we plotted the group 6 network one, which is beautifully produced here. Yes, and also before I continue, yes, you can actually export this graph. You can save it as an image or a PDF or even copy it to a clipboard and can paste it somewhere else for future reference or maybe for your report or something. Okay. So with the results that's given here, so the first one is the betweenness. Okay, so as you could see from this graph down here, Capitata, Brew, Doggy all have a value of 4. That means they are the ones in the middle of the graph, okay, with everyone else being 0. Okay, so actually Capitata, Brew, Doggy, as you could see from the diagram here, right, are in the middle of the whole set. So they have a betweenness of 4. But yes, this is easy to see, but just imagine if it was a large data set. iGraph will be able to just go through it and just give you the details or the calculation that you want in a matter of seconds. Okay, so when we come to the closeness, okay, so the closeness, as I said, was going to calculate the distance between one node and all other nodes, okay? So the closest is a fraction. Okay, so using Solomon in this case, right? Okay, so Solomon to get to Capitata has a length of 1. Let's assume every connection has a length of 1. Okay, so Solomon to Capitata is 1, right? So we're going to add all the links up. Okay, so Solomon to Capitata is 1, Solomon to Doggy and Brew is 2 each, so that's 5, right? And Solomon to Vinny and Samuel is 3 each, so that's 6. Okay, so we'll have 1 plus 4, that's 5, 5 plus 6, that's 11. So 1 over 11 is going to give us the 0.09 as stated here. So basically using that calculation, you could actually calculate the closeness of all the other members. Okay, and also the degree, okay, so the degree tells you how many times each node has a connected link. Okay, so Solomon has 1, just Capitata, Brew, Doggy all have 3, Vinny and some also have 1. Okay, and the density. Okay, so the density actually is a calculation of the, it's a fraction actually. So it's the number of edges, as you could see in the design over there, or the diagram over there, over the number of possible edges. Okay, so this one has some sort of a calculation. So it actually is the number of the nodes in there divided by, so it actually has a calculation. So it's n into bracket n minus 1 divided by 2. Okay, so the number of edges here is 1, 2, 3, 4, 5, 6. Okay, so that will be 6 divided by the formula I just gave, which will be n. So n will be the number of edges or nodes. That will be 6 times n minus 1. So that will be 6 times 5. That will be 30 divided by 2. That will be 15. Okay. Okay, so 6 divided by 15 should give us the 0.4 as stated here. Yes, so that's correct. And the diameter, which is 3, as I said, the diameter is the longest distance. And as you could see, so let's say from Vinny to Samuel, it's 1, 2, 3. And the distances in the next line actually confirms. So it actually gives some sort of a matrix link between all the members or the edges of our data set. Okay, so between Solomon is 0, Solomon capital to 1. But as you can see, the largest value in all these sets is 3, which confirms the diameter. Okay. Okay, and the clicks, as I said, so the clicks actually gives you a result of what you specify as the minimum number of connections. And as you can see, we specify 3, and that states that any 3 nodes in our network which are connected together, it should give us. Okay, so it gave us Capitata, Brew, and Doggy. As you can see, Capitata, Brew, and Doggy are all connected together. Yes, and the articulation point, as I said, so if these nodes are taken out of your data set or of your data presentation, that's going to render the other members of the node incapable of connecting to others. So we are going to, like, with those members who are the articulation points, and we're going to have a break in the network structure. So they are going to be different networks instead of having them together. So those are like the conduits, okay, like the people who connect others to the rest of the team. Okay, and also that also gave us Doggy, Brew, and Capitata. So looking at the, if Capitata, Doggy, and Brew are not in this data set, we're going to have Solomon, Vinny, and Samuel all acting independently as different networks. Okay, and also there's the components where actually states the members of our data set and gives us how many times they appear in order. Okay, so basically, so when it comes to sample data, like the one we just created, iGraph and also the calculations there could actually make sense of our data set and actually give us a direction as to maybe a way to go in regards to analysis of our data set. And as I said, yes, so this is a simple data set. Just imagine if we had a CSV file with thousands of edge points or thousands of nodes using iGraph, which is a package that could be used in our studio, will actually make things easier for us when it comes to the analysis and also in putting in the data. As I said, I created, so let me minimize this part. So I created one where we manually created the data sets, right? And I created one where we actually had to read an input file, preferably a CSV, and that did the work for us. Okay. Yes. So basically, I hope the group has been able to convey our iGraph experience to the rest of the class, and hopefully, this could be a pivot or a moving point for the others to maybe learn upon it and maybe do something wonderful with iGraph. But in my personal opinion, I think iGraph is an amazing tool. And also with the knowledge of R, you could actually do marvelous things with the iGraph package. Okay. So Kelly from Group 6 again, and thank you for your time and stay blessed.